Let's take a look at this. We're trying to find the antiderivative of x to the third minus 2x squared plus 3, okay? Hopefully, you guys are getting a little bit quicker with finding the antiderivative of these functions. So, we're basically going to take the antiderivative of each individual piece. So, what's the antiderivative of x to the third?
1/4 x to the fourth.
1/4 x to the fourth. What about the antiderivative of the next piece?
2/3 x to the third.
And what about the constant 3?
3x.
3x, and of course you cannot forget your plus c. Of course you cannot forget your plus c. Now, what that is that is known as a general solution, okay? Whenever you take the antiderivative of a function, you always have that constant of variation with the c. That is known as your general solution. We can actually find the value of c if we're given particular values of the function. So let's take our same problem of the day example, and let's actually know this additional piece of information that f of 0 is equal to 2. Well, f of 0 equal to 2 is essentially the point 0, 2. So we can use that additional information as well as the general solution from before to find the actual value of c, which will give us our function. So all we have to do is we just have to plug in 2 for f of x, 0 for x, and then we would solve for c. All of these terms cancels out because 0 times anything is 0. So we see that c is equal to 2. So our function, our particular solution is 1/4 x to the fourth minus 2/3 x to the third plus 3x plus 2. That function has a derivative of x to the third minus 2x squared plus 3, and it crosses through the point 0, 2. Let's look at this one. We're going to take the antiderivative of 3 minus 2x squared in order for us to find a general solution for f of x. And then we're going to use this information here, f of 1 equals 1, to find our particular solution. So what's the antiderivative of 3?
3x.
3x. And what's the antiderivative of negative 2x squared?
2/3 x to the third.
And then, of course, we have our plus c. Okay? So now that we have our general solution, our general equation, we want to find a specific one that actually goes through the point 1, 1. Remember, this is your x, and f of x is equal to y. So I'm going to plug 1 in for f of x. I'm going to plug 1 in for x. And I'm going to solve for c. So that's going to give me 1 equals 3 minus 2/3 plus c. 3 minus 2/3 is 7/3. Then I'm going to subtract 7/3 from both sides, and c is going to equal negative 4/3. So my function has a derivative of 3 minus 2x squared and goes through the point 1, 1. It's 3x minus 2/3 x to the third minus 4/3. You try this one on your own. All right, so what was the function before you found the value of c? What was the antiderivative of 3x squared minus 4x plus 1?
X minus 2x squared plus x plus c.
Very good. And don't forget, you can always check yourself to make sure you found the correct antiderivative by taking the derivative of this. So I'm just going to check you real quick. Remember, to find the derivative, I bring the exponent down to the front. So that gives me a 3x. I subtract 1 from your exponent. I multiply that 2 and 2 together, and then I subtract 1 from my exponent. The derivative of x is just 1, so very good. You can always check it by doing the derivative of what you got. How do I find c?
Plugging in 0 for x and setting it equal to 12.
Plugging in 0 for x and setting it equal to 12. We have another similar situation where all of our terms cancel out, so c is going to be equal to 12. So my function, my final answer is going to be 3x squared. Nope, looking at the wrong thing, sorry. X to the third minus 2x squared plus x plus 12. Questions on finding particular solutions?
No.
All right, we're going to do one more problem, okay? This one is probably, I guess, on like the harder scale of like an integration question where you have to find your original function. It says a curve has gradient function f prime of x equals ax plus 1, where a is a constant. Find f of x given that f of 0 is equal to 3 and f of 3 is equal to negative 3. So what you essentially need to do is you need to use this information. You need to use this information to find not only the value of c, but you also need to find the value of a, because it's asking you to find the full function. So you still go through the process of taking the antiderivative of your f prime of x. All right, remember, a is just the constant. So remember, you add 1 to your exponent and you would divide by, you do 1 over the new exponent. So this turns into 1 over 2 ax squared. Did everybody get that?
Yes.
Yes.
Okay. And then of course the antiderivative of 1 is just x. And then of course we'll have our plus c. So this represents our function. So now you need to use the additional information to find a and then to find c. Okay? Or find c and then find a. It kind of depends on the information that you're given. So since I know that I have a point 0, 3, I'm going to plug 3 in for y, 0 in for x, and I'll be able to find c. Clearly all of this cancels out. C is equal to 3. So now I have the function 1/2 ax squared plus x plus 3. Now I can use this point to actually find the value of a by plugging in -3 for f of x and 3 for x. Questions up to here? Okay, so now we're going to go ahead and solve. So it's going to be -3 is equal to 1/2 times a times 9, and then 3 plus 3 is 6. I'm going to go ahead and subtract the 6 over. And then 9 times 1/2 becomes 9/2. Going to multiply both sides by 2 and divide both sides by 9 to find the value of a. And so by using those additional pieces of information, I'm able to find not only a, but also the value of c. So my final function is f of x is equal to 1/2 times -2 x squared plus x plus 3. Or negative x squared plus x plus 3. And that is how you find particular solutions.